Perfect timing, Rob, and good afternoon to everybody. Today's subject is a second of two. We're talking about managing visual aids compliance in the 21st century. And Rob is our presenter today after giving him a month off whilst a bit of self celebration. We remembered we celebrated our 40th anniversary of Tailor Made Systems and MARMS, and so that was last time, but now we're back to the serious stuff, managing visual aids compliance in the 21st century. Of course, what's different about the 21st century from the previous century? Well, we've seen, for various reasons, the rise of low-cost airlines. We're seeing a massive move. I was commenting to my colleagues, and by the way, I'd like to give a special shout out for Melbourne Airport, all of you out there. I'm being looked after this week. I am, in fact, at Melbourne Airport at the moment, where I'm working with Gavin, Scott, and his team, the teams on the training of the new Sign and Pappy tester, which they have just purchased from us, and a new MARMS photo bench. So thank you very much for that, guys, and thank you for your hospitality this week. But this is where I'm doing training. So I said to Gavin I'd give them a special shout out. So hi guys, and thank you for everything. So we're now coming back to the 21st century. We're seeing, and I was saying to Gavin, when I first started flying, I think probably at least half the passengers were business travelers, and probably with leisure being the smaller part. But that has changed a lot, particularly post-COVID, and now we're seeing the huge rise in low-cost airlines and leisure travel, being the prime sector, from what I can see. And that's given rise to a lot more traffic. We're already above pre-COVID levels of traffic, which is incredible. But also, we're in a much more litigious world in terms of aviation, and so airports and airlines need to be much more careful to take care of things because of the nature of the claims culture. We're also seeing a tougher regulatory environment, which puts added pressures on us in terms of managing our visual aids. We're seeing a shift towards a rules-based regulation, where they've shifted the responsibility from really a shared responsibility, where the civil aviation authorities work together with airports, and so there wasn't so much an us and them, but nowadays the regulators set the rules and they expect airports to follow them. And woe betide any airport that has a problem and isn't able to demonstrate compliance, competence, and adequate record keeping. And that's something you'll see reflected very much in our management of visual aids in the 21st century. And of course, the third leg to our development is the new technologies, where we're seeing new light technologies. We're seeing the rise of the LED. Certainly wasn't there in the last century. We're seeing the control systems, the electronics and digital world emerge as leading into our terms of our management of our visual aids. We're seeing a greater emphasis on inspection and maintenance, moving from a fixed basis of maintenance, just inspect and fix, to a more progressive, proactive, preventative, and anticipating future fault type of maintenance. And that's what Rob's going to be talking about today. So I'd like to hand over now to, well, first of all, let's do the introductions, Rob. If you could go on to the next slide. I'd like to welcome today Tony Smith, who hasn't yet joined us. I'll just send him a message because he was on our practice session a moment ago. But Tony Smith will be joining us on our panel later on at the end of Rob's presentation. Tony, of course, inventor of the Pappian, world expert in all aspects of airfield lighting and regulation. Keith, of course, famous to you all as the leading trainer. Trained many of you that are actually on the call today. I know I've met many people on my visit to Australia have been asking me to say hi, Keith, because you've just recently conducted training for them in Melbourne and also in Auckland. So some of the guys were down in Auckland with you, so they all say hi. So Keith is with us, and Rob Billingham, of course, is today's presenter. I've been working with him now for 15 years. Absolute star in terms of software and technology, which of course is coming to the fore. I wouldn't have thought airfield lighting inspection and maintenance would be so reliant on software, but that's where the way in which the world is moving, and that's what Rob will be talking about in terms of the managing visual aids in the 21st century. So over to you, Rob.
Thank you, Robert. As Robert said, I've known Robert now for 15 years. I've been at Tailor Made Systems for the last 10 years, and I've spent most of that time developing TMS's MOMS dashboard system and all the reports that go with it. I run a very busy software and support department. Yeah, so I'd like to share with you some knowledge on managing your CMMS system, demonstrating your compliance, and it's a second part really to a presentation I did 2 months ago, where we discussed CMMS. So I'll start the presentation by saying previously on TMS Tuesday. I'm not sure anyone else has ever said that. So first of all, what is a CMMS? We talked about this last time. It's a computerized maintenance management system. So it's software that helps a company manage information and processes. So this applies to many other areas of business, not just ours. And the ultimate goal of CMMS is to boost equipment uptime, whatever that may be. But in our case, that means assets on the runway, taxiway, and apron. So we're in the business of asset management and the status of those assets, keeping them running smoothly, and uptime is money and time. So last time we looked at the core components of a CMMS. So it's at its heart, there is a database, which is a database of assets, which are managed by the system, and all of the parameters of those assets. Mainly those assets in our case are the AGLs, the runway lights themselves. But it also includes other equipment. There's all sorts of assets on an airfield. We've got our CCRs, we've got cables, pits, transformers, signs, PAPIs, windsocks, anything that's needs maintenance. It can be tagged, and it's an asset within our system. So the functions of a CMMS. So first of all, as I mentioned, there's that asset management. There's the configuration of those assets within that database and keeping that up to date. Then there's the monitoring of the status of all of those assets, which moves on to work order management. So your CMMS might be interfaced with some other engineering software, which passes work orders down to engineers in the field. So we interface with that and pass work orders on. And when those work orders are closed, information comes back about how long the job took to perform, what parts were used, and what now is the status of that asset. Is it fixed, or does it need further remedial work? So information from all of that can be fed into the preventative maintenance plan. So this plan must be fluid. It must change based on knowledge from this previous maintenance and inspection. You don't need to keep talking lights that don't need to be talked, or you might need to talk lights more that need talking more. Time is money, so those plans have got to constantly change. Then we come into stock management. If you're repairing things, you need a stock of parts. So in your workshop, you need to manage that stock. You need to know what you're using and make sure you've got enough stock there and you order it when you need to. And then also the stock of assets themselves, the runway lights, you need to keep a certain amount of them on the shelf. So we need to monitor what's on the shelf, what's currently in repair in the workshop, and what's out in the airfield. Then all of that, what we talked about there, can be audited. And last time we looked at a whole myriad of reports which are available via the MIMS dashboard. To produce reports for regulators and for management and for engineers as well, to help them with their work in the field. And those reports lead into performance indicators. So we're constantly looking at management level reports and KPIs and targets that we need to achieve. So these reports help us keep on track with all of those things. Again, last time we looked at this wheel of measure, maintain, monitor, and manage. Now, last time it was a much simplified slide. This is a much nicer version of it. So we start at the top left with measure. So this is everything we measure on the airfield. Our photometric trailer, our luxometer measuring apron lighting, our photo bench in the workshop, sign and pappy tester. All the data from all of those things feed into the CMMS database. So then moves into maintain. So after you've measured, there's a certain amount of assets that you need to maintain. Things need to be fixed, improved, changed. And so we schedule work to do all of those things. And we decide when, what, and where that's required. And then after that maintenance, we need to monitor what we've done. And we can do that by the dashboard and its reporting. So we can look at those results from what we measured. We can look at the audit of what we've maintained and what work has been done and produce reports on all of that. And then based on that data, we can manage what we've done. We can produce heat maps, histories, audits, and we feed back round into measure by the actions that we're required to do on the airfield to improve things and fix things based on the three previous stages. It's a constant cycle. It goes round and round. And I will say it now, I'll probably say it at the end, you cannot manage what you can't measure. That is our motto. And you may have heard Robert say it a few times. Okay, so today, and last time we looked at a lot of the aspects of a CMMS, from runway testing, PMs, maintenance, all that sort of thing. Today, we're going to focus on the workshop system and how the CMMS helps there and how we track assets through from the runway through the workshop system and how we manage assets and stock levels and repairs and things like that. Okay, so we're going to look at tagging and warranties. All assets have a warranty period, and that needs to be managed. And we also look at from the data we collect, we can look at mean time to failure of assets and are they lasting the expected amount of time. So we need to maximize the efficiency and reliability of our assets. We need to track them with tagging, and we need to monitor our warranties. And then we need to look at stock, and all of this to minimize downtime and ensure a smooth operation of our airfield. Okay, so how do we identify lights? How do we track them? So on the runway itself, one way is to use tags buried in the ground. So we use glass tags. They're called RFID tags, and we bury them around about 50 millimeters down under the tarmac. So usually we decide on a particular side of the assets to place them, and we'd like to put them all on the same side as we go along down the runway. And we usually recommend placing them at 75 millimeters from the asset itself. And bury them at 50 mil deep. That is fine for reading with our wand reader and our torque wrench. So once we've installed the tag, so we drill a hole, pop it in the ground, we fill it with resin mortar. We'd use our RFID hand reader to test that that tag is working. And then at some point we'll come along with a tablet PC and a reader, and we'll associate all of those assets into the system. So the RFID tags and the locations all go into the database. So we reference this location by the RFID tag number. And I must stress at this point that what we're talking about here is a location, not an asset itself, not a lamp, but the location where a lamp goes. So the lamp itself is a separate asset, which is something that we need to monitor through the workshop system, and that is put into a location at some time further down the line. As an alternative to RFID tags, we could use GPS. So that's advantages and disadvantages. So global positioning systems have been around for quite some time. We all know it from our sat navs. So here we're using GPS on a tablet or maybe on a phone running an app. And it gives us an accuracy of 4.9 meters, around about that, or 16 feet. So downside to it is it can be blocked by buildings. It's not usually a problem in the airfield because it's a nice open space. You have problems with atmospheric conditions, so thunderstorms and things can cause issues. And also the design and the quality of the receiver itself. If it's a cheap phone or tablet PC, it may not have as good a receiver in it. This can mean that the 4.9 meters is a lot further. And it's often the case with runway lights that, especially inset fittings on close to taxiway junctions, lead-ons, lead-offs, where lights are closer together than 4.9 meters, and just using the GPS alone would not identify which one we're standing by. So we have an improvement to that, something called RTK, real-time kinematics. So this can give us centimeter accuracy, and this is a new development for us. So what you have is a base station somewhere on the airfield, which is a surveyed location. So we know its exact position. It's connected to the internet. Then you have your device in the field, your tablet PC, connecting to GPS as it does normally. Also connecting to this base station over the internet. And it's a secure private connection just for your airport, your base station. No one else can use it. The RTK modules in the field are called rovers. So it could be in a vehicle or connected to a tablet PC with an engineer walking around. And we get a correction from the base station. So that corrects the GPS from the satellites down to centimeter accuracy. It knows exactly where you are on the runway with triangulation, and it corrects that GPS signal. So that could pinpoint which light we're actually standing by, but there still are advantages to actually having a physical tag in the runway too, as it's categorically identifies which lamp we are at. In the workshop, we need to identify fittings as well. So the physical lamps themselves, we identify those with what we call an encapsulated tag mounted on the power cable. So we can see in the photo there. So our workshop testers have an RFID scanner mounted inside them. So when you come to do a test, you simply have to scan the tag. The system knows exactly which fitting you're testing. You don't need to enter a serial number or look through drop-down boxes on the software. Software will know which lamp you're testing and what the setup of that lamp should be. Whether it's a red-white or a red-red, and it knows all of the parameters we need to test against. So it speeds up testing and accurately tracks the fitting through our system. So other ways of identifying lights themselves, we could use barcodes or QR codes. So the products themselves, the actual fittings, they've got barcodes on them. And this one here has got a barcode which specifies the PID address of the unit. So this is the comms address of this lamp in the control system. So it's already a unique identifier. So we can use that within our system to identify the fitting too. But the problem with QR codes or barcodes is they could become damaged over time and unreadable. So fitting the RFID tag to the cable does have a huge advantage. Okay, so when we first commission our CMMS, we need a lot of information about the assets themselves, including where they are. And this information is usually specified to whoever's commissioned, whichever company's commissioned the system. And the information could be taken from an existing airport asset management system. So it may be just a dump of assets from that system. Assets are generally split up into areas and zones. So at this time we group the assets into areas and zones. An asset needs to have a photometric type. So what sort of light should be at this location? The can itself has specifications, what size light can fit in it, what bolts the fitting itself has for torquing. So the latitude and longitude must be specified accurately to an agreed number of decimal places. It'd be good if we specify circuit details that can be used for CCR testing, and sort of maps of circuits within the reporting system. So as much of this information must be specified as possible, and it's usually passed as in terms of a sort of a survey, and then it's imported into the CMMS system on commissioning. So accuracy of this data is key. It can be updated later, but it's good if it's all accurate to start with. The data can change going forwards. We might recommission a runway. We might have a runway resurfaced, and we need to look at all the positions of the lights again. So yes, the information is updated, added to as we go along, but it's good to specify it accurately in the first place. And again, this is not the lamps themselves, this is the locations of the assets that we're talking about. Then the lamps themselves. So this is in the workshop system. So all lamps have a manufacturer, and they have a fitting type. So is it a centerline light? Is it a taxiway, TDZ? And during the commissioning of the system, we need to set up all of this information along with a lot of parameters about this lamp type, which usually come from the manufacturer specifications and documentation. So things like the elevation, the azimuth that we would expect to find when we test them, and what error values we can allow within those parameters. Fitting height, its beam width, and of course the all-important candela. What's the standard we're expecting if we test this fitting in the workshop tester? So all this information, when we configure individual fittings, we specify the manufacturer, fitting type, serial number, then the all-important RFID tag. So we should know that, so that the tag we fitted on the cable. The color of the lamp, is it white, red, white, red? Then we could look at warranty information. So this may be important later if we're looking at mean time to failure. So the warranty might be that when you buy the fittings, they're in their boxes and their warranty is running down, they're on the shelf, and you've got 3 years warranty. It might be that the manufacturer allows you to have a warranty from the day you first use them. So we need to record that within our system. So we need a first use date and that warranty period. Is it 2 years? Is it 3 years? So then we can use that to figure out, obviously, the date of expiry. Then also a lifetime. What's the specified number of hours this fitting should last for? 50,000 hours, 40,000. If we could interface with the control system when we're collecting data, it would be possible to get the actual running hours. And are the lamps running full capacity? What step are they generally running at? 50%. If we could record this information, then we could feed this all in here when we're looking at this mean time to failure, and has the fitting lasted for the expected lifetime. So data quality is crucial. So data quality is an assessment of whether the data is fit for purpose in the particular context that we're using it. So if we want to perform some analytics or AI, we must have good data to start with. All of that configuration data must be correct and it must be completed. It's no good just to say manufacturer unknown, we'll fill it in later. We need to put all these details in from the beginning, so we start collecting a good amount of quality data. In the future, we're going to want to analyze that data. And if we run it through AI, it's got to be good from the beginning. So there's an old saying in computing, going back to the 50s or 60s when we first started: garbage in, garbage out. So it goes without saying, what you put in has got to be right if you're expecting some decent results out of the system. So 5 traits with the data that apply. Got to be accurate. So all those lat longs must be correct. Your test criteria must be correct as documented. All those parameters must be set up correctly. It must be complete. You can't fill in some of it later, leave it blank, I don't know. Reliability. Does it contradict other sources of information, such as the airport's asset management system or GIS system? And is all the data relevant? Well, if you're given a survey to complete, yes, it's all relevant, you've been asked for it, but okay, so maybe your asset IDs, 20 characters long. Do they need to be 20 characters long? Is all of the information in that field actually needed? Are you overcomplicating it? And timeliness. Is the information up to date? Can we use it for real-time reporting? Has something changed on the runway since this was exported? And we need to make sure it's up to date before we commission this thing. Okay, so let's talk about tracking lamps through the workshop system. So we've already talked about the location of fittings on the runway. The lamps themselves, they're either in one of 3 places. They're either actually fitted in the runway, they're in stock on the shelf, waiting to go out if they're needed, or they're in the workshop in repair. And if they're in the workshop being repaired, we'd like to get them repaired as quickly as possible and onto the shelf so they are being useful in case they're needed. So on our dashboard, we can have a panel where we track how many we've got in stock of each of these locations. We can produce a simple bar chart of where things are. If we click on one of those bars, we can drill down into that location and see by fitting type how many we've got. So how many TDs headlights are on the shelf or in the workshop. It's all information we need to know, and we know that information because we track it through the workshop system and the MARMS engineer system using the RFID tags. Okay, so how do we track this then? So to figure out where a light is, we need to use both tags. So if it's in the runway, we scanned the fitting and we scan the location, and they're paired together, so we can track it and we know where it is in the runway. So we know what area and zone within MARMS engineer it exists in. If it's in stock, it's going to be in stock for one of 2 reasons. It's come back out of the runway for some reason, placed into stock, or it's been repaired and placed into stock. If something that comes out of the runway, it goes into stock, but then it's quickly moved into the workshop if it's got a problem, where it's tested, and we can use that test result to analyze the issues. So it's important to test as soon as it's removed from the runway. So this report here is an audit of a single fitting and we're looking at its history. So it starts up being removed from the runway. So it's in stock. It goes into the workshop. It's had a test on one side. Then that's fine. So we move it back into stock. Then we install it on the runway, and sometime later, its LED driver fails. So we're back into the workshop again. We tested it to prove that's the issue. We've done some remedial work, and that's been recorded as to what we've done to it. Back into stock again, and then back out onto the runway. So you can see we can track the history on assets, how often it's been tested or repaired, and we know how long it's been in the runway for, how long it's been in the workshop for. So we can produce those mean time to repair and mean time to failure figures. Okay, so let's look at the best practices for documenting maintenance to give us that accountability and traceability. Okay, so how do we remove a fitting from the runway then? So we're going to use Martin's Engineer for that. So we know where the fault is because it's marked on the map. We locate the fitting, drive there. We scan the tag of the fitting at the location. Then we select Do Action. This is within the Martin's Engineer tablet software. We select Replace AGL. We fetch that fitting out. Then that fitting, as far as the system is concerned, is gone into stock for now. Then we can replace it with one that we know is good, which we just brought with us. So, as I said, when things come into the workshop, we must always test them initially. So we're going to test twice. We're going to test before and after repair, and maybe during if we've got an ongoing issue and we need another test in between to help us. So all the tests we do on a particular fitting are audited, and we can search this audit by fitting type or by date, and we can see who's done the work and the reasons for failure or the reason for pass. In the workshop tester software itself, we get some Isocandela pictures. And we've got the ability there to record any remedial work that's done. So we can tick whether the LED's been replaced, or the prism, or the cable, or the unit's been aligned or cleaned. We can record what action's been taken. We can also make some comment in a freeform entry box, and all of this information comes through into the dashboard reporting. So we've done our test. Isocandela diagrams are a tool that we have to help us diagnose the issue. So in webinar 42, we went into this in some detail for photometric testing, and it's exactly the same for the photo bench. The diagrams are in far more detail, at much higher resolution. But we've got all of the same tools there to analyse the Isocandelas. We can add guides to the images. We can enhance them. We can change them so we can enhance the darker areas. So this particular fitting we're looking at, the actual LED driver, the actual LED itself could well be upside down on the A side because you've got all the light pointing up to the top. So we're expecting the light to fill the circle or the ellipse as it is on other fittings. So we can see the alignment is out in this case. So that's a fail. And we've got a figure there, the elevation achieved. We've also failed on candela as well, on intensity, because the brightest part of the beam isn't within the ellipse. Okay, so remedial actions taken during repair. While we're doing our testing, we can record those. And they come into the PhotoBench Engineer software and then through to the database. We can make those additional comments. But in the dashboard reporting, we can then track how many actions have been taken, how many fittings have needed a replacement prism, how many have needed cleaning, how many have been scrapped and had to have an entirely new fitting. And maybe we can track we can track faults and look for epidemic failure. to ongoing issues with a particular type of fitting. So all of these reports can be filtered by manufacturer and type, so we can look for the patterns and ongoing failure and address those. It's also possible to interface the system with the stock management system, so we can track those spare parts that you're using. we can track how many prisms you've got in stock, how many cables, how many LED drivers. So you know when you've got to order new parts, and you can keep the workshop running smoothly. So we fixed our light, we've done the remedial work we needed to do. Both sides should be good, so we'll get it back in the tester now, and we get, once we had a pass on both sides, the unit is returned into stock by the system. Okay, then so to put that back into the field when it's time, when it's needed, we'd go out to a location where we need to change a light. So this may not be the location where it was in the first place. It can be put anywhere you like. Obviously, got to be the correct location for that type of fitting. You'd scan the RFID tag, perform another replace AGL action. Then you'd be asked to scan the encapsulated tag on the lamp itself, so the system can identify which fitting you're putting in there. It moves the removed lamp back into stock and the repaired lamp back onto the runway. So within our dashboard reporting, we saw last time a lot of different maps that you can produce for tracking things. This particular map is useful. We can look for ongoing faults in a particular location. If we show the number of replace AGL actions that have been taking place at different locations, and here the darker circles are showing us where there have been frequent changes, we could have a possible circuit issue or an issue in the CAN, something geographical. It's something that you wouldn't see from tabular data or just your list of faults. Next, stay ahead of maintenance schedules with a visual indicator system to track time to failure. Okay. So mean time to failure and also mean time to repair. As I said before, we can track these metrics by all of that data that's come into the system, all of those repair actions and tests, and tracking it in and out of the runway, into stock and back into the workshop. We can look at how long it's been in the workshop for and how long it's been in the runway for. And on our top level dashboard, we can show these figures by manufacturer. I've just put them on each of these here because I don't want to discuss any individual manufacturers here, but it does allow you, the airport, to create these figures. And it gives you the ability to work with manufacturers to improve the standard of the product you're receiving. If you could feed back to them the issues you're having, they can work with you to solve those problems. If we click on one of those manufacturers, we can drill down into the fitting types, and we can look at these mean time to failure, mean time to repair for each different fitting type. And we can look for any particular issues we think are going on here. So if we've got very low figures for a particular type of fitting, then we need to investigate further. So the figures here I've got for demonstration purposes. These aren't actually from any real airfield. It does give you analytical proof to aid in any investigation into an ongoing issue with a particular type of light. Whereas before, all you could do is point fingers. We drill down from that chart into some tabular data about the individual fittings. We could start to look at, obviously, the manufacturer, the fitting type, but then we can look at this warranty period. So we know when these fittings were first used, and we know how long they should last in days, which gives us an expiry date. And we also know a lifetime in hours, and maybe from the control system, we might know the number of hours it has actually been running for. and whether they're running 100% or 50% of capacity. So if the lamp is to fail within an acceptable period, we can show that in green, and that is a good figure. That's good news, because we can use that information then to plan our preventative maintenance, and we know how long these fittings should last. If we've got an amber fitting, that means that it's past its warranty period, so we can't go back to the manufacturer this time, but it's underneath, it's lower than its expected lifetime. It's not lasted as many hours as specified for whatever reason. We may need to investigate that. And then in red, we'll mark anything which is failed within its warranty period, so that we can take this up with the manufacturer for more help information. So let's look at a real world example of how the workshop can help us on the airfield. We're going to look at something called rapid serviceability, or RSS as we call it. So this is all about you doing a photometric survey, and you've got those results on your dashboard, but something has failed. You've got some adjacent failure on a center line or an edge, and that red cross is going to be there for a whole month until you get to survey again. So you get your next closure, and you can take the trailer down again. Okay, so you may have fixed the issue by a MARMS engineer, but the problem is still showing in your serviceability. So RSS gives you the opportunity to correct that based on the results from the workshop tester. So you can test a fitting that's in stock in the workshop tester before it comes out into the field, prove it's good, put it in the ground, and then the results from the workshop tester are substituted into your photometric results until the time of your next photometric test. So using MARMS engineer, you record the fact that you've put that light in the ground and where it is. The dashboard reporting is updated with the result from the workshop. So some conditions to this. The lights must have been tested in the photo bench within the last 12 months. So that's the best before date on the test. And because we know what date that was tested, we can reject that fitting at the point of installation in the engineer software. We can't support elevated fittings with this system because of the nature of them. With the elevation and azimuth, we can't guarantee that they're putting to their locations accurately and aligned correctly. So the result doesn't reflect what it was in the photo bench. So inset only. The Isocondenser diagrams don't come across from the workshop because they're much higher resolution than the photometric ones. So at the moment, we just bring across the intensity results, candelas. We assume that you put the fitting in the right way around. So it's a red right, it's pointing the right way. And if you do put it in the wrong way around, we hope that would be picked up on a visual inspection at some point. So we assume that you put it in right and the result can come across. In order to use RSS, you must have MARMS photometrics, you must have a trailer, you must have an engineer system, and you must have a photo bench to do that testing. And you must have fitted all of your lamps with encapsulated tags so they can be tracked. So if you've got a light that's out or it's failed its photometric test sad face, so we can replace this with the MARMS engineer software, as we've seen earlier on. So then we scan the tag of the new fitting that's installed, and we're all happy and working. So the system has substituted that value. And what you'll see is on your course bar chart reports, the yellow triangles at the base of the bars show you which lamps have been substituted. And we would hope that a substituted result is better than what was there before, and we've got a nice green bar. and that value is then reflected through into the runway serviceability report. And we also show you a yellow triangle on the bar. There is a map layer where you can track RSS fittings as well, so you can see where they are in the airfield. And then these substitutions come through then onto the front dashboard page with a nice green tick to make your runway serviceable. And then, as I said, when you do your next real photometric test with the trailer, hopefully they test out good and the results are replaced with real ones. Okay, so that's all from me. I'd like to go back to the panel now and we'll look at questions.
Okay, then. Well, thank you very much, Rob. That was really interesting and informative, and I'd like to thank you. That as the participants in this might appreciate, attendees may appreciate, a lot of work goes into preparing these presentations and delivering them, so I thank you very much, Rob, for your time and effort there. To the panel now. Well, first of all, just I'll repeat this at the end, just to let you know, everybody, that we're having a holiday next month. So August is our TMS Tuesday holiday, but we're going to be back on the 1st of October. But just to let you know, there will not be a TMS Tuesday in August. But to the questions on today, first of all, I have a question here. What do the panel think the future holds for airfield lighting maintenance? Now, I've seen this question already. So if you consider the future, this is what's happening at the moment. Where do we see the future going? I had a chance. So if you could just consider that, panel. I've had a chance to think about this question as the presentation has been delivered. Very much. I see a great necessity and benefit for the industry as a whole as the key stakeholders working more closely together. I don't see enough cooperation in today's visual aids and airfield environment. So we're talking about on the regulatory side of things, the government side, governing national strategies and of course determining legislation, the airlines, the manufacturers, the suppliers and services, and of course the airport operators, representing most of you actually in this webinar today. And of course, I include airfield lighting maintenance within that. And within each of these areas, I see a huge benefit for us working more closely together, more cooperatively, to come up with optimal solutions that will support greater safety, greater efficiency. And by that I mean, investment requires a rapid return on investment, of course, which means improvements in maintenance which result in greater runway availability. That's where the efficiency comes and the return on investment. It's not about spending less pennies on the actual maintenance itself. It's about working smarter to improve runway availability. As I said earlier, we're seeing even more demand on our airways, on our airports now than pre-COVID. So we need to minimize the amount of time spent on the runway so that planes can occupy them and effectively increase capacity. And of course, the third leg of the model for all the stakeholders to concentrate on, and we cannot ignore, is net zero. So we need to somehow work towards a better efficiency. I heard CO2 emissions. The airline industry contributes quite a significant portion to that now, and we've got to work towards reducing that as much as possible towards net zero as we work forward, and that cannot be ignored as well as safety and efficiency. So that's where I see the future of airfield lighting maintenance, working in conjunction with all the stakeholders to achieve these goals. Hopefully I've bought you enough time, guys, to consider your views. Keith?
Well, yes, I am. I'm off mute. Good. I've been looking at the questions as it's come down, and I think the first question that came up was a proactive and engaged approach. What advice can we give if clients the client approach, that means the airport approach, I assume, is less than proactive and engaged? And what are the implications, risks, costs, etc.? Well, clearly, and what you've just said, Robert, that when we're looking at the industry as a whole, then we are governed by regulations, and the regulatory authorities then push out a lot of regulations and standards, etc., in the form of ICAO with their annexes and design manuals, and the local standards for the national authorities, regional and national authorities. And what they're actually saying today is putting the emphasis directly on the airport authority. So the airport authority has full responsibility to demonstrate compliance. What are the risks, the implications, the costs if we are non-compliant? Well, and where does AGL fit into the wider aircraft operational requirements? Well, when we look at the operational requirements, AGL is a visual system, and but most aircraft operations are operating under IFR, the instrument flight rules, rather than VFR, the visual flight rules. And when we are operating in the instrument flight rules, we are a fundamental component of ASMEX, the surface movement guidance. And clearly the operation of an aircraft gets pushed, the permission to push back into the movement area, starts its engines, and then transits from that apron, that parking area, to the runway for the runway holding position for takeoff, enters the runway and takes off. And for a arriving aircraft, it's the reverse. It lands on the runway and then leaves the runway. So we go then onto the taxiway network and transits to the apron. That is where potentially then there are a lot of possible issues when it comes to surface movement guidance. And when we're looking at the advanced surface movement guidance, when we're looking at ground movement radar and multilateration, etc., so that we need to know where the aircrafts are on the taxiway network, then we all know about the follow the green technology, using our visual aids on the taxiway center line we follow the greens, and therefore we are an integral part of aircraft operations. We are not a facility on an airfield that we've got some lights. As a friend of mine who's no longer with us used to say, "Oh, this is Keith, he's my British mate. He changes the bulbs on the airfield." I used to say, "Yep, that's what I do." And we know it's a little different to that. We are an integral part of aircraft operations. And one of the big issues that we have in light fixture serviceability, certainly on a taxiway center line, are those tugs that pull the aircraft around the airfield and skim off the top of our lights, because they are transit from the when they are not carrying pulling an aircraft. They will take, and the tug arms will skim across the ground because they drive too quick, and we have some major issues. Now, of course, when we run our photometric tool across to measure light output, then suddenly our our lights are no longer compliant. But we also have the issues with spares. So there is a complete integration of our visual aids into the requirements for safe aircraft operations. So we're not just a facility, we're an integral part of aircraft operations. And I think many people tend to forget that. So the introduction of collecting data, as Robert said, it's you can collect lots of data, but what do you do with it? And this is where that question came in. What advice do we give if the client's approach is less than proactive or engaged? Now, it's something that we can't have a direct influence of, but what we can do is to provide the data and for airports to make those decisions. It's quite a complex answer to a pretty simple question, but the reality is then airports are directly responsible. And you are correct, Robert, when you're saying how active are the regulatory bodies of today. And I personally find that the regulatory bodies are not as active as yesteryear.
Yeah. Thank you, Keith. And
it's a long old answer, I know, but it's the reality.
It was a good, very good question and a very good answer. And looking at it now, if our clients are less than proactive engaged, I would say that we have to be even more proactive engaged, and that's all of us, whatever discipline we come from. I'm afraid, yeah. So yes, thank you for that, Keith. Now we're up to the hour, but I'll take one more question here. I've been asked for examples of cases where data, where the measurements have been used proactively to actually generate benefits and stimulate activities and improvements for our customers. So I asked the panel, can you give any examples of cases where, real life cases where the information has been used, the big data has been used proactively to stimulate improvement?
Yes, Robert. Our friends at Stansted, I know for definite that they had to support their case for changing to LED lights. This was sort of back before lockdown. It's been some time ago. They used the mean time to failure figures to support a business case for changing to LED. And then after they'd changed everything to LED, they used the reports to prove the benefits of what they'd done. And I remember Stansted presenting this at one of our user group meetings.
Yes, so that's an excellent example, and I think that's something important to be remembered. It's not only supporting a business case with facts that give sort of uncontrovertible evidence for building the case for doing something, but also actually measuring that the benefits have been realized after the change or the investment has been made, to ensure that you actually get what you paid for, a rapid return on investment. So that's an excellent example. Any other examples you can give me, guys?
Well, I think what Robert's just said there, Robert, is it's before, during, and after. That's the way I look at things. What do we do before? You think we know. When we use the tools that are available to us, we're collecting the data, and then thereafter we can make realistic decisions. And one of the questions that has come up on the Q&A is the MTT, mean time to failure, an add-on to our software, and is it already available within the software? Well, the amount of data that the MARMS technologies, and I'll call it MARMS technologies generically, in the MARMS technology, you're collecting data. And it's like any measurement system, it's what you do with the data. You collect data, you analyze the data, and then you present it and use it. They're the three functions. Collect accurately, repeatedly, as you've already said many times. You then analyze the data, and now we can analyze vast quantities of data in real time and make these realistic decisions. But whatever decision is made associated with periodicity and frequency of maintenance, you make those decisions based upon the data that we have collected. And that's clear in the Annex 14 in the standards. You make decisions on frequency and what you do according to the data you collected.
So you, in other words, you cannot manage what you do not measure.
Correct.
Yeah. Thank you for that. I've just, by the way, those of you may be concerned. Where's Tony? I've managed to speak to Tony in the course of this webinar. Unfortunately, the Great British Telecom has contrived to take his local Wi-Fi network down, and he's unable to communicate. His network is down locally. We've made telephone contact with him, but he's unable to get a data connection. So he apologizes for not joining us. But I asked him the question, and he said that, you know, his major beef was, again, coming back somewhat to what I was saying earlier about regulatory matters. The current regulations, and specifically ICAO ADM Part 4, the standards talk about in terms of airfield lighting maintenance, in terms of inspection and repair as the approach to maintenance, whereas they need to be modified now for the reason we're making today's webinar, because in the 21st century this dated approach to fix on failure, that's no longer a way to approach maintenance. We need to be using big data and modern digital techniques to be able to manage our maintenance more efficiently, and that means actually looking at predictive methods and methods to identify areas of failure and to optimize maintenance processes and procedures to avoid any issues on the runways and taxiways, such that we are able to minimize the downtime of those valuable assets and improve runway availability and airport capacity. And that's where the benefits are going to come. So did anybody, I'd like again also just to give a, as we wrap up for today, unless anybody has anything else to add, I'd like to wrap up today by just once again thanking my hosts. A final shout out for Gavan and the team in Melbourne. Thank you so much for having me. It's been an absolute pleasure, and it will be for the rest of the week, I might add. And thank you, audience. Thank you, attendees, for participating in today's webinar. Without you, there would be no point. And so we really appreciate your participation. I'd like to thank the panel for all the hard work they put into preparing these webinars and their contributions on the day. So thank you, Rob. Thank you, Keith. And of course, thank you, Damon and Felicity, who put all of this stuff together for us, and all the technology and everything without which this just wouldn't happen. And I wish you all a very nice, I hope you have some kind of summer holiday, although I might add it's winter here where I am, which is quite unusual, quite extraordinary. But so you all have a nice summer holiday. We'll have a nice winter holiday, and I'll see you all on the 1st of October. Thank you very much, and happy holidays. Goodbye.
Cheers. Bye.
Bye.
Bye, everyone.
Bye.
Yeah.